There's a lot of different products out there that talk about purifying the air with these UV lights. I think a lot of them may cause a little bit more harm than good.
Any device that puts an additive into the air as part of their technology is a no-go for me. We're trying to remove stuff from the
Yeah.
air, not put stuff into the air. First of all, 99% of our industry installs these devices and don't even know if there's any pollutants in the air. What's the best filter? You just can't slide in the 3M allergy buster into a 1-inch slot and call it a day. They're giant killers.
Hey, what's up, everybody? Got John Ellis here again. And if you were following my channel last year, John Ellis is the indoor air quality guy, the guru that teaches the HVAC guys how to really dive into indoor air quality in homes and buildings, how to diagnose issues and how to fix those issues. Took a class with John last year. Great to have him back on here. So John, introduce yourself to the group and tell us, what you've been doing for the last year or so since we talked last.
Yeah, well, first of all, Eric, thank you for having me. Always a pleasure. Anytime we can get together and talk geeky talk about HVAC and building science and indoor air quality, it's always fun, right? It's both a blessing and a curse. You walk into a building, the first thing we look at is the HVAC. But again, my
That's
name
the
is
curse
John
part.
Ellis. Yeah, that's the curse part. Pleasure to be here. Thank you for tuning in. Yeah, I've been just briefly, I've been in this industry for 45 years. I've done it wrong, learned how to do it right. Yes, I am known as the indoor air quality guy. Uh, Spent a lot of time and a lot of my career helping people who are severely compromised, both respiratory, immunal, environmentally sensitive. And that's been awesome. I've been doing building science for 20 years. I did a project in California for the housing and urban development, low income. On one project, I did over 200 blower door tests, and then you learn how to get pretty good at doing blower door. Sometimes, if you're in the same building, this was across three buildings, but you don't even break down. You just pop it out of
Right.
the frame and go to the next one and set it up. We did combustion analyzing on both the heating and like cooking equipment and ventilation and tightness. And yeah, and that was really cool. And you really learn how to turn building performance into a production kind of thing when you have that many units to get done. It was fascinating. Of course, 45 years HVAC, been a member of NCI for, my goodness, going on 19 years. And so I was an early adapter to performance contracting. And so that gives me a really good breath on how to tackle indoor air quality from a multidiscipline, kind of point of view. But
Yeah.
yeah,
Are you in Arizona now? Or New Mexico? Where are you at?
yeah, I'm in New Mexico. I live up in the mountains. I live in a cabin, a different way of life.
Yeah.
People often say, "Oh, what's your kind of mechanical you got, John?" I show them a hatchet and a chainsaw because I have no mechanical. And it's like, well, how does that look like for indoor air quality? Well, it's different. But I got a
Yeah.
really nice wood burning stove that seals good, but it's a different way of life. I've got some trees that have already been fell. I got to start bucking them up. I got to start blocking them. I got to start splitting them and loading the wood shed. I've got all my hoppers full and get ready for winter. So it's always that cycle. So I'm at
Yeah.
7,400 feet elevation up in the Sangre de Cristo Mountains. So we get
Well,
snow
that's
and all that
beautiful.
fun stuff and all kinds of animals, and it's fun.
So are you in a dry climate then? The reason why I asked where you live is because I think it's good to frame conversations based on climate zones because not everything that we talk about is going to be directly applicable to every climate zone. But you're in a dry climate, I assume.
Yes, and you bring up a great point, Eric. And if you remember in my class, I always say the why never changes, just the how. And so, having my business originally in California, dry climate. Right now, I'm in New Mexico, high elevation, dry climate. I'm 2 hours away from that humidity belt. As soon as you cross over into Texas, hit you like a brick wall. So that being
Yeah.
said, I really had to go on the fast track when I started teaching nationally and start taking that dive into psychometrics and dehumidification and really looking at all the effects of humidity and dew points and what that looks like. And so, to your point, absolutely, every climate is going to be different. And you get up north, yeah, Indiana, Michigan, Minnesota, upstate New York, like Rochester and Buffalo. They get it all. So they're running dehumidification in the summer. They're doing humidification in the winter. They're running ERVs year long, and it's a whole different animal. And then, of course, you've got the southern states like Houston, Louisiana, Alabama, Georgia, and the likes, all the way Florida, and that's your humidity belt. And man, that's a whole different animal.
Yeah. Yeah, because I'm in Kentucky and it's definitely hot and humid this week. It's going to be pretty much 90 to 95 every day this week for the next 7 to 10 days. And the humidity is off the charts. I woke up the other day and I think it was 74 outside and the dew point was at 72. And all my windows on the outside were just raining. So it's pretty muggy and gross. So it's summertime humidity. So I want to talk about this. So like if you're in a humid climate zone and you're watching this, then you're probably dealing with some of the problems that we're talking. And so one of the questions I have for you is this is everybody's got an opinion on this. I have my own. I'd like to hear from you. What's the ideal indoor relative humidity that you should keep your house at in the summertime for good air quality and for comfort?
This is a wild card, and I get asked this all the time. And Nate Adams and myself, we had some great conversations about that. If you don't know, he's the house whisperer, and so
Yeah,
we got some standards that have been put forth to us. Oh, 50% relative humidity. Now, right now we are talking about summertime, but 50% relative humidity, depending on what climate you're in, you could have your windows raining because you've got too much humidity in the winters. But boy, there's some things that come with high humidity. One, we've got a chance for microbial growth. Dust mite colonies thrive in anything 50% and above. And so then there's the human body. We start to get too low, and then the mucous membranes start to dry out. And I've been in homes where they just were like killing the latent side, and then actual like the veneer on the cabinets was starting to dry out. So it's a balancing act. So can we hit and maintain a 50% relative humidity for a hot climate like what you're experiencing now? That would be that would be good. Can we climb to 60? I don't know. To your point, your outside temperature and dew points are pretty close. Pretty easy to hit that. And so
yeah,
it's all about recognizing where our dew points are, running those psychometrics. Can we can we do the heavy lifting with our refrigerant cycle on our HVAC system? If we set our sensible heat ratio and get our airflow down where we can maintain a refrigerant cycle and do a lot of latent work, well, we can do a lot of lifting. But I'm telling you, man, where you're at and all those everybody in the humidity belt, supplemental dehumidification is almost a must for the space and for some unconditioned spaces as well, like a crawl space. And then understanding how is that humidity from outside getting in and hitting that. So we got our ambient outside, ambient indoor, and to your point, hitting dew point, right where those two intersect. Understanding how to identify where that's at is gonna go a long way. So it's an uphill battle, and I don't envy, uh, you guys at all, and we're having some pretty wild weather all over the place. I just did a quick trip to, Utah, and man, it's on fire. Colorado, yeah, they're having some trouble, and that's really low humidity. I mean, send some our way.
yeah, yeah. So you said a few things I want to unpack a little bit there. So close to 50% relative humidity, I think is ideal. I think 40 to 60% at the max is kind of the range of where you want to be any time of year, really. And so, like, over 60% is generally where you start growing things in houses that you don't want, right? Your molds, your
Yes.
funguses, and things like that. The second thing that you pointed out was kind of the ways that you control humidity. And one of those primary ways is with the air conditioner. And the air conditioner, you know, cools the air inside the house. But one of the other things that it does is it removes moisture from the air if it's been sized properly. So you kind of touched on the airflow that goes through the air conditioner and the size of the air conditioner. Both of those things play into the ability for it to dehumidify the air properly. And that also goes into the how long it actually runs, right? So if you have a system that's an air conditioner in your house that's too big for your house and you constantly have high humidity problems, I would pay attention next time that AC turns on and it's 90 or plus outside, and see if that air conditioner actually runs for 30, 45, 60 minutes of that hour. Because if it's sized properly, it really should be running pretty much consistently. If it turns on for 5 or 10 minutes and turns back off, it's short cycling. So it doesn't have enough time for it to pull that moisture out of the air. The other thing that you touched on for humidity control that I want to talk a little bit more about is dehumidification. So, I actually recently just installed an Aprilaire E100 whole house dehumidifier because of the same issues that you're talking about. So, my house in the summertime generally will be between 50 and 60%, usually 55 to 60%. Air conditioner runs a whole lot. I've got two systems. I even have a dehumidification mode on both systems, but it's still not enough to remove that moisture and offset that incoming air. So, the first thing that you really want to do if you're talking about moisture control is control where it's coming into the house. So limit the amount of air leaks coming in and out of your house. Same with duct leakage. If you have duct work outside the living space of your house, and then the next thing would be properly sizing the air conditioner and then thinking about the dehumidification. So if somebody is at this point now where they're considering a dehumidifier for their house, and I'm not talking about just like the standalone that goes in your room or whatever, but a fully ducted system, whether it's connected to the HVAC system directly on the return side to the supply side, or it's discharging into the living space. What do you tell people that are considering a dehumidifier to try to solve some of their moisture problems in their homes?
Yeah, and, so let's, we're both touching on a lot of points. So, properly sized, we gotta be there. And air conditioning is doing 2 kinds of work, sensible and latent. An oversized piece of equipment, even if you're trying to set to a sensible heat ratio, is going to short cycle. So what does that mean? It runs, it's changing the temperature of the air, and then it satisfies the thermostat and turning off. We never even reached steady state. You know, we're not even like 20 minutes into a refrigeration cycle to hit steady state, and then really start doing that latent work, pulling that moisture out. So first and foremost, that, and so an oversized system isn't going to do it. Then if we've got duct leakage, even predominant return, pulling that unwelcomed air that may be full of humidity and heavens knows whatever else. But even a leaky supply system can draft and pull air in, but it can also upset our pressure differences and then start pulling that undesirable air full of latent humidity into the home. And then once we have that air, we could pull unwanted air from an attic space and hit dew point in the ductwork. Now we're really in trouble. And so then getting back to dehumidification. So there are two ways to set it up. So one, you gotta look at how many pints of water you need to remove. And so, looking at your humidity, and right now we're looking at relative humidity, but there are some charts out there that can kind of give you an understanding on how many pints of water we're generating based on relative humidity. So that's first thing, because just like air conditioning equipment, sizing is important, right? And then there's two ways to do it. Can we incorporate it into the HVAC system? Well, absolutely, we can. Can we run it independent of the HVAC, meaning pull air directly from the house and
Yeah,
then put it back in, but we're gonna be gaining some heat, or pull it directly from the house and put it into the air conditioning system, to recirculate. Um, those are the primary ways. So you would, one would be pulling air and then putting it right back in through the system, or pulling it directly from the house. I would like to pull it directly from the house. But,
yeah,
space is always a commodity, and your setup and where it's at, if you've got a closet set, man, you're really pressed for room and what you're able to do, especially with a sitting on a closet with a return air, underneath the cabinet. Well, where can you put this? So, um, space and application is always gonna be an issue. We can pull that humidity directly from the house and run it constantly would be great. And then incorporating it into the HVAC system can also do some good work for you. But to your point, if you're running and your system satisfies, but you're still bringing in that air latent humidity from somewhere. Well, you need to get rid of it, and if you satisfy the thermostat and then everything shuts down, but you're still bringing humidity in. So there's a lot of things here. We're talking building science, we're talking mechanical, having an independent dehumidifier that can run constantly on a humidistat that's in the space. Well, that might be the answer too, and just research. Now, are you going to add heat? Well, yeah, because you're running a refrigeration cycle. There is a compressor, and that discharge air is going to be warmer,
Warm and dry.
but to your point, dry. Then the thermostat should, if you're going to bring your temperature up, should identify that and then bring your cooling back on. So location's going to be important. Where's it at? You know, where's your space? Got a two-story house. Obviously, when you're looking at stacking effect, that heat will rise, but it also takes the humidity with it. So then maybe that's the place to have it. And so there's a lot of moving parts.
Yeah. So I'll just explain real quickly the way that I did it in my house. So I have a basement in my house, covers most of the first floor. The basement's always cold in the summertime, like just about every basement that I've ever been in. It's cold in the summertime. My kids don't want to be down there in the summertime. So what I don't have in the basement is a dedicated return pulling any air out of the basement. But what I did was I connected the intake for the dehumidifier to the central return that's in my living room because it's pretty close in the basement. So I connected that. It's pulling air from that central return, and then it's discharging it basically out into the main area of my basement at the low point underneath my staircase, middle of the house, and it's pushing that warm, dry air into the middle of the basement. Well, within 24 hours of this thing running, my kids were like, "Oh my god, the basement's comfortable again," and they actually want to play down there. So this is like a extra side benefit that I hadn't really banked on. I knew it was a possibility, but it's very comfortable down there now. So I got a
Yeah,
usable basement in the summertime. So it's just if you've got a basement, you live in a humid climate, and you can make this kind of thing work. You don't have to dump the air from the dehumidifier back into the system to circulate it back through. If you have a cold basement, maybe you just want to dump it in the basement.
absolutely. Yeah, that's a great point. And so the flip side to that coin is that you're removing humidity, you're putting warmer, dry air into a space that is typically cooler because it's subterranean. You got a lot of mass there, so you're not getting a lot of heat gain. The flip side to that is I've been in hotel rooms in the middle of summer, July, very humid, and it's running a PTAC that's doing very little to zero latent work, and that
Right.
room is cold and clammy. Everything
Yeah.
feels damp. That is super uncomfortable as well.
Yep. So what can somebody do if they're in a hotel? Is there anything, any setting that they can change on that PTAC to make them more comfortable? Or are they just at the mercy of the hotel's stupid designers?
They're at the mercy of whatever it's gonna do, and they do pull a certain amount of outside air in just by design. So they're not only are they not doing any latent work, but they're also pulling a little bit of humidity in, and and they don't even have like if they had a dry mode, like some systems have like a dry mode, you know, and it'll run for a while, but they don't even have that, and it's just the nature of the beast. They're running air at a pretty fast speed across that evap coil, and it's just not doing any latent.
So I have a question about hotels, actually. I was just in a hotel probably 3 weeks ago. Unfortunately, it was for my father-in-law's funeral. But one of the things that I've always noticed when I'm in hotels is that little port that's in the wall that's supposed to be the bath exhaust vent and allowing the moisture to get out. That moisture never works. I mean, the moisture removal hardly ever works. So, like, my understanding of those things is it's supposed to be a gravity fed exhaust system. Why don't they work? And what should an HVAC company be installing in a hotel or a motel that would actually work? Because I actually used my little smoke pencil and I got a video of this. I'm going to create a little short out of it. But there was absolutely nothing going into that vent and back out after I took a shower.
Yeah. So what do we need for air to move?
You need a pressure
Pressure
difference or
difference
a
in an
temperature
opening.
difference or something. Yeah.
Yeah. Even if we were to, the principle of a fireplace or wood burning stove is you heat that chimney, right? And then once it gets heat, it starts to draft. And so that is creating the pressure difference. But in a hotel room, there's not a whole lot of stacking and there's no pressure difference, especially on a lower floor. So you have no movement. So
Yeah.
let's put a fan on it. And
Yeah.
I've done uh, some investigative work where they did have a fan and it was multi-floor, and someone on the first floor was smoking, and the smoke was getting in to the rooms above. Uh,
Yeah.
because the fan was located in the bathroom itself using a common chase. So they created a pressure difference with a bathroom fan, and it went up and it took the path of least resistance and didn't go all the way to the roof. And some of it was getting in to the rooms. So the
Mm,
answer to that would be do one central fan at the roof, have it run constantly at low CFM, and you'll always be drafting everything up from the space. But I know what you're talking about. I've been in hotels too, and there's a little grill on the wall. It's like, huh, and I don't hear a fan running, and it's like they're not doing anything.
yeah, and for whatever reason, they like to take the grill and they turn it upside down so that the louvers are facing up. So, like, not only does the air have to go up and then down into it and then back up, it's so ridiculous. So, from a design perspective, I had to bring that up. So, so Mr. Air Quality Guy, we've talked about humidity, and I know you have, what is it, 5 or 6 things that you like to profess that encompass, healthy homes. So why don't we go through those real quick?
Yeah, so I call them my 6 key principles or pillars. The foundational, however you want to call it. But
Yeah.
and it always starts with thermal comfort. So we are in the comfort business, are we not? And then I get some pushback, and people, well, thermal, yeah, we're running heating, we're running air conditioning, we're conditioning a space. But what people failed to realize, and with my client base, that people who are severely compromised are very, very sensitive to temperature differences. They are also very, very sensitive to pressures. They can feel pressure. They can feel barometric pressure, and it upsets the way they feel. So yes, on its face, a face value, yeah, oh, thermal comfort, yeah, that's what we do. But as far as indoor air quality, that's very important on how clients that are compromised feel, and that their overall well being and how they're feeling is huge. And so the next would be filtration. So every piece of equipment we go up to should have some type of filtration on it. And that runs the whole gamut on how well they're working and MERV ratings and how they fit in the housing, where they're located, static resistance, and PM capture. So all that. And we I taught a class at NCI a year ago, a year or two ago, about the science of filtration. And so there's a lot that goes into that, and even the designing of a filter. And so the next would be humidity control, too much or the lack thereof, and the why never changes, just the how. So how you tackle it is going to be contingent on your climate zone and what you're experiencing for humidity. And you know, obviously, I'm in a drier climate, and you're not, so it's going to be different.
Yeah.
But again, the why never changes. So we've got thermal comfort, filtration, and humidity control, and the next would be definitely ventilation. I think just for an overall, you know, good environment, ventilation is important. We look at ventilation for many reasons. One, in commercial applications, we look at ventilation for pressures in a space, and then we look at it as dilution is the solution for some pollutions, right? So if we're looking at high carbon dioxide levels, ventilation can dilute those, bring it down to a reasonable um, rate. And then TVOC is the same thing. And ventilation for mechanical rooms, so we get a good draft, would be, and now that's for pressure differences. And there are mechanical rooms that are shut tight, and we've got natural drafting hot water heater, and the flue gets warm and we hit steady state, and they're still not really drafting the way they're supposed to, because the room, 1 CFM in, 1 CFM out, right? Pressure difference in an opening still isn't allowing that water heater to draft. Just by adding a little bit of ventilation will just pop that bubble and let everything draft. So we look at ventilation on many different for many different aspects in building,
Yeah.
in comfort and reliability, and indoor air quality. And so thermal comfort, humidity control, ventilation, and did I miss one? Uh,
Filtration, I think you said already.
yeah, filtration. And the next would be building pressures. Now, this gets out of a little bit out of HVAC and into building science, but building pressures are huge. And even as an HVAC guy, if you're running load calculations, the single most important number that you can put in as an actual measurement would be your infiltration number. And
Blower door number.
everybody, your blower door number, right? And everybody likes to go default. And man, you can default your way through a load calc and make it jump through hoops and do anything you want. But if you really miss that, your that particular one, yeah, that could be the difference in a good design or not. And then finally,
Yes.
my last one would be pollutant identification and source control, source control, source control. If we can identify the pollutants in the space, that gives us a good idea on where those pollutants are coming from. Are they outside coming in? Are they from within the space? Is it behavioral, which is the wild card? Is it something, that the occupants are doing? But if we
Yeah.
can identify the pollutant and go after the source, then all the other stuff we want to do has a fighting chance. And
So
that's
let's
my
talk
six
about
key principles.
yeah. Let's talk about identifying pollutants. So there's a whole bunch of consumer products out there that are being sold now. There's definitely a lot of professional grade products out there, but for a homeowner who wants to identify like what's in the air inside their homes, are there some products that you recommend that are relatively affordable that they should buy and check out first?
Well, absolutely, and with technology, it's getting better and better and better. So I would be in trouble if we weren't in this conversation, and I didn't mention the Haven IQ room monitor. That does a fantastic job, and it's reasonably priced. Air Things is another one. Arnett makes some wonderful, and they've just come out with a whole catalog of radon and TVOCs and carbon dioxide, and I think carbon monoxide, and they're
Yeah.
small, they're compact, and they're very reliable and accurate. And so there are some things at our disposal, but then there are also some things that go away on the cheap side. And the old adage, "You get what you pay for," and I would question the efficacy on how well they measure, right? And then so if you're basing your whole decision on a substandard monitor that's not, may or may not be giving you accurate data, that's touchy. Now,
Yeah.
I've got all kinds of testing things, and I'm able to measure, with very high confidence, with good accuracy. Now, each one of those handheld devices that I have start to add up considerably. For instance, my particle scanner that reads in five size ranges is called Lighthouse. I mean, that's a $3,500 measuring device, right?
Yeah.
And
Most
so
people aren't going to pay for something like that.
most people are going to have that. So there are plenty of things, and and if you are using something like the Haven IQ or the Air Things, and you get a measurement and you're concerned about it, the next step would be maybe we get someone in that can take a more accurate reading. But I'm a firm believer that everything we do should be based on data, and
Yeah.
so data is king.
So when somebody's looking at these different products, whether it's an Air Things or the Aeronaut or the first one, I can't remember, you said
Haven.
The Haven IQ. What should these things at a minimum be reading? Like temperature, relative humidity, PM 2.5. Like what are the core things you think that it should read? Otherwise, it's just a waste of money.
And that's a great point. And almost all of them measure temperature and humidity, but we can do that at a thermostat, right? So, but those
Right.
are always
Yeah.
seem to be added. But we need to be measuring carbon dioxide. And the reason I say that is depending on who you ask. I mean, um, is that going to affect people? Will my clients that are compromised? Yes, because the higher the carbon dioxide, it's depleting oxygen, and so that becomes a problem. But for most healthy individuals, a high 1200, ppm carbon dioxide isn't going to be detrimental. But what we as professionals do, we use carbon dioxide as a proxy for understanding how our ventilation is, and you
Okay.
can just open a window and let a little breeze in and watch those carbon dioxide numbers fall. So
Yeah.
that's a good proxy on how well the home is ventilating.
Ventilating. Okay. It's
Yeah.
carbon dioxide.
At a minimum, they should be measuring TVOCs. Now, there's a problem there as well. Now, is it important? Well, yes, but it's a broad stroke of the brush. We got like 16 VOC compounds that we look at. And to name a few would be like benzene, dialene, formaldehyde, some isopropyl. So, but there's 16. Half of those are more prominent than the other, but those are what we look at. And if we see those in our space, then we know we should probably do something about it. But when we read TVOCs, it could be all of it, or it could be half of it. It could be two of them. So we have to be a little bit careful about TVOCs. Now, if we're getting elevated levels, right, then we know, hey, we've got something going on, and maybe we should go ahead and bring some better equipment to speciate, separate those out, so we can again identifying, hey, I've got high formaldehyde. It's triggering my TVOC count on my air things.
Yeah.
Okay,
Yeah.
well, formaldehyde, we know what some of the sources are. Remember? Identification, source control. TVOC, we don't have any identification. So, I mean, we could be chasing rabbits down every hole trying to figure out what the T is in the TVOC. So that's total, right? So
Okay.
separating them out. I think
Okay.
a good monitor should measure carbon monoxide as well. So, and then, do we want to add radon into that? And so, I mean, we could keep going and keep going. So, I think if we just cover that, so we temperature and humidity, we covered carbon dioxide, TVOCs, radon, right, and carbon monoxide. Those are probably some good solid ones. Um, I get asked. Well, I ask my classes all the time. Hey, y'all got a problem with radon? Oh no, we ain't got no radon. Really?
How do you know?
And you go to the radon-epa.gov and bring up the map, and it's like, hey, we're right here on the map, and look, you got radon. So people discount that a lot, and it's not to cause a panic, but it's just something to be aware of. So I think if we, those are some good solid things that we can measure.
So what about the PM 2.5 particulates? What I mean, people talk a lot about these microparticulates and what they can do to the body and the brain and stuff like that. Can you elaborate on
Yeah,
that just for a second?
sure. And I left that out of the list, and I thank you for reminding me. Yes, PM 2.5 is important. And so recently, and I say recently in the last decade, we really started paying more attention to PM 2.5 and ultrafine particulates. And the reason being is the reason that is because when inhaled, the ultrafine and PM 2.5 and smaller can actually get into the lungs, enter the bloodstream, and then get into the rest of the body. And so, that is problematic, and it's really a problem for, uh, young children that are still in the developmental stages, so their lungs are developing. Um, I think, PM 2.5 exposure can be attributed to the higher rates of, childhood asthmas and overall pollution, depending on where you're at, but I think that's a contributor and then other pollutants as well. So that's why we pay attention to PM 2.5, and that seems to be the standard now. Now, when we take that school of thought, PM 2.5, and transfer that over to filtration, you're going to find that a lot of filters don't do a whole lot of work in the PM 2.5 range. When we get to the MERV 13, we start doing some work in that realm.
Yeah.
MERV
This is a
8,
good
not so
segue.
much.
Hold on. Before we go down the MERV path, let's back up a second because now you're going to start talking about air filtration, which is one of your key things there. And people always want to hear about air filters. What type of air filter is the best air filter? Should I get a MERV 13? Should I get a MERV 8? Should I get an electrostatic MERV, air filter or whatever? What is a MERV rating and how does it relate to air filters? And then talk about which of those MERV ratings or which type of air filters are the best to get those particulates and really clean the air out.
That great segue and a great question being asked of all of us. And and to kind of give that some context, I get asked all the time, John, what's the best brand of HVAC? And I always say properly designed, properly installed, properly commissioned, and properly maintained. I don't care whose sticker's on the box. Well, what's the best filter? Well, a properly designed filter, because you just can't slide in the 3M allergy buster into a 1-inch slot and call it a day, because cause and effect. Now, I will say this: I have tested the 3M allergy buster with my particulate counter, and they do very, very well. But their loading curve is short, their static resistant is off the chart, brand new, and you're only going to get in more trouble as it loads. So they're giant killers, right? Oh, I slid in the 3M. Now I'm calling for a service call because my coil's frozen or the compressor is running hot and going off on high temperature because we've slowed the air down on an undersized ductwork even more. So we've got liquid going back, and oh winter's here and we got allergies, so I slid the 3M, and now my heat's going off because it's going off on high limit, right? So that
Yeah.
the mechanical part is really important. So it has to be designed properly. MERV, minimum efficiency reporting value. That's ASHRAE 52.2. It's a standard in which we use to level the playing field so everybody's graded on the same system. And that's based on airflow, resistance, and capture. And so what they do is, in a controlled environment, they have a certain amount of PM at different size ranges. They release it, they catch it on the other side, they weigh it and see what percentage removal we have. And so that's what goes into a MERV rating, if you will.
Okay. And the higher the MERV rating, generally the more stuff that it's going to catch. But as a side effect, the more restrictive that air filter is on airflow through it if it's not sized, to your point, and designed properly for that system.
Correct. It's all about surface area. It's all about surface area, baby. So the more surface
Yeah.
area, the easier the air will pass through that media with less static resistance. And so
So when
then
we're
there's some.
talking, go ahead.
Well, so then the other side of that equation is, if you've got a 4 or 5 inch extended pleated media and you slide it into a filter cabinet that maybe wasn't the original cabinet that came with that filter, and you close the lid and it's like, man, it says MERV 14 on it, so I'm good. And then it doesn't fit in the filter housing and you've got bypass. Well, guess what? That MERV 14 just went to a MERV 11 the second you turn the system on, because it's not able to do the capture it's meant to do because of bypass. So there's a
Yeah.
lot of determining factors.
So that's actually a really good point. So if you have what John's basically saying here is if you have an old media filter rack on your system, or maybe it was an electrostatic media
Bingo.
filter, and then that thing died a long time ago, and you said, "Oh, well, this is a big cabinet. I could put a 4 or 5 inch filter in there." And you go on Amazon and you find the Filter Buy or one of these discount filters. Those air filters are always slightly smaller than the opening that it's made to go in for whatever reason, And so when you put it in that filter rack that's not designed for that specific filter, there's extra space between the cabinet and the filter that air bypasses the filter and goes through. So you're not getting as much air filtration as you thought out of that $30 or $40 discounted filter. So like I have Honeywell media filter racks, and I can only buy the Honeywell that fits that media filter rack. And I'm okay with that because the discounted one is only about $5 cheaper. These things last me anywhere from 3 to 6 months, but the one that actually is made for it is the one that works the best for it. So you really need to use one that is sized accurately. Those filter buys are always a little bit too small.
Yes. And they do that so ease of application. They can sell
So they'll
more of
fit in
them.
more different boxes.
They'll set it fit in more boxes. Yeah, and that's intentional that way.
So you're a product ambassador for what's called the Dust Free 16, which is a super duty industrial strength. I mean, like health, hospital quality air filtration system, but they're made for residential as well as for commercial systems. So why don't you talk about what kind of led you to develop that product and how it differentiates from the media filters and some of these other products that are out there that people can buy?
Yeah, and thank you for asking. I had the wonderful privilege of working with Dust Free, which was recently acquired by Rector Seal. But I went to Greg, the owner, and we had sparked up a relationship. And I said, hey, you know what? There's a part of this industry that's got a void going, and we have an opportunity to fill that void. And so I told him what I wanted to do, and at that point in time, he was the sole owner of the Dust Free, and he's like, "Hey, John, I like it. Let's do it." So I wanna preface all this by stating that one, I did not invent the mousetrap. I just built the best one, right?
Yeah.
There are other products out there very similar to the one that we developed, the Dust Free 16. So that being said, it was a tall order. I brought 45 years and 19 years of NCI training and airflow and everything that I've learned and my indoor air quality experience from the field into the labs with the engineers. And I worked with a guy named Devin, wonderful young man. And it's like, how many attics or crawl spaces have you crawled in to work on HVAC? Zero. That's where I came in. 'Cause I've got 45 years of crawling and installing and measuring, and so it was a tall order. I told them this is what I needed to do, and they were up to the challenge. So we went from concept. We did take a look at our competitor because if we're gonna go to market, we need to go big, and so we were able to beat all competitors across the board, hands down, and that was our goal. And so, from concept to a prototype, uh, my tall order requests, ultra low static drop, filter life, ease of application, several different applications, ease of use for the end user. I mean, the contractor, but most importantly, the benefits and features for the the consumer.
Right.
That's a lot. And
Yeah.
and so as we started, the whole process starts with, uh, concept and drawings, and then we started running computational fluid dynamic, and it's a software program that lets us plot airflow and static resistance and velocities and PM removal, and, um, and so as we're running the computational fluid dynamics, that gave us, kinda data that we needed to build our filter media. And so just so you know, we couldn't get the filter media that we wanted in the United States. So we had to get it from Europe. And more specifically, I think it comes from Milan, Italy. So we told them here's what we want. We want to use all five filtration methods. We want a very robust electrostatic attraction. We want to have MERV 16. We want to be able to hold that MERV 16. And so they were able to um, uh, come up with a filter media. We procured it. They send it to us. then we have a company in Texas that pleats it and makes it and puts it together. Glue bead technology. So within the cardboard frame, there's no leakage, right? The filter is gasketed. So when it's in the housing, there's no leakage. And
Yeah.
so we, several rounds of, we got the first batch of filters, went to the lab, and we weren't getting where we needed to be. And so we went back to them and we ended up going from 1 7/8 inches to 2.5 inches to be able to accomplish what we wanted as far as static resistance, airflow, and removal. So once we got the second batch back, had it pleated, went to the lab, the numbers started looking good, real good. So on a 2-ton system, I mean a 5-ton system, 2000 CFM, 492 feet per minute velocity, we were able to bring it in at a 0.18 static resistance at 98% removal of PM and substantial removal of PM 2.5 with a 3-year filter life.
So you just said a whole bunch of numbers that a lot of people aren't going to know, but when we're talking about air filters and in HVAC systems, they create a pressure drop when air moves across them and they start getting loaded up with dust and stuff like that. And that
Yes.
pressure drop is measured in terms of static pressure. So the really high MERV rated air filters generally have a higher pressure drop going across them because they're more restrictive. What you're saying is you've designed a system that still gets the great air filtration, but it doesn't have the crazy pressure drop across the air filters.
Yes, and just to lay that all out, a filter is meant to move a certain amount of air at CFM, at a certain velocity, at feet per minute, through a certain amount of net free area at for our filter media with a certain amount of PM removal. And that's where the computational fluid dynamics is really works to our benefit, and minimizing material procurement, trips to the lab, and accountability. I mean, that really helps us narrow it down. Otherwise, it starts to be ridiculous research and development just to get there. People really don't
Yeah.
realize what it takes just to get to a filter for design. And so taking all that into consideration, um, we finally got done at the lab and got the numbers where we wanted. Now, our published performance data is very conservative, 0.18 at 2000 CFM, 492 feet per minute, and on the up to 3 tons, 1200 CFM at 492 feet per minute. We're coming in at a 0.14. I've got guys who've installed these in the field, a retrofit, not even brand new units, and those numbers are coming in lower, more favorable. One interesting fact is our performance data, our filter at the end of its loading curve after 3 years is at where most filters start brand new. That's mind bending. So wait a
Yeah.
minute. At the end of 3 years, at a full loading curve, your static resistance is where most filters start brand new.
Yeah. Right out
Yes,
the box.
right
Yeah.
out of the gate.
That's
And
awesome.
so once we got through all that, it's time for our credentials. So we went to the lab. We had our official ASHRAE 52.2 testing done. And so we brought our filters in for MERV 16, official. And Greg says, John, that's not good enough. We got our ASHRAE 52.2 credentials for the whole system, the cabinet and all. Nobody
Okay.
does that because they know that all bets are off once that filter goes into a cabinet and it doesn't fit tight. So we've got dual credentials, MERV 16, the filter by itself and the cabinet installed. Is that amazing
Yeah.
or what?
Yeah. It's an awesome product. So if somebody's interested in learning more about the product, what's the website they should go to check that out?
So you can go to Rector Seal, put in dust free, and then search dust free 16. And all the performance data is there. And then we sell them right now through truetechtools.com. And so they have them in stock, And again, there's up to 5 tons. So that would be like a 4 and 5 ton unit for, 1400 CFM and 2000 CFM. And then we have, or 1600. And then we have the smaller one that goes all the way up to 3 tons. And man, I'd love to see everybody using them and sending me pictures.
Yeah. So, kind of an adjacent topic to air filtration is air purification. And there's a lot of different products out there that talk about purifying the air with these UV lights or with different methods. And some of them may be beneficial. And I think a lot of them may cause a little bit more harm than good. And I want you to touch on this really quickly about which products in particular, and you don't, if you don't want to say brands, you don't have to say brands, but if they have certain features that homeowners can look for, like, hey, I don't want to buy something that has this and this as a side effect. Why don't you kind of explain that real?
Sure. Let's start with UV technology because it's the easiest, right? Been around a long time, tried and tested, right? But like anything, has to be installed properly. It's based on a three-legged stool, and I've got two three-legged stools for you. For microbial growth, we need moisture, food, and oxygen, right? So we have a wet evap coil. There's the moisture. We know we're going to have oxygen, right? So the only thing we can get rid of is the food. You want to
Yeah.
get rid of any of the three, we don't have microbial growth. What's the food? Filtration. So let's get back to a tight system and a tight duct system. Now there's no food on the coil. Now there is no microbial growth. But that being said, if we get to a point where there is some food on the coil and we get to where there is a need for UV technology, three-legged stool, the intensity of the UV spectrum, UV, UVC, UVA, far UV. There's a lot now. There's even LED UV for mini splits. So those are the spectrums, right? And then the intensity, 27 nanometers seems to be the sweet spot for residential. Then there is, so we got intensity, and then we've got the dwell time. How long is that UV, the spectrum at 27 nanometers, being able to uh, reflect or shine onto a microbial, which is normally on a surface? How long is that exposure? And again, I don't have a number for that because it's so subjective. One, what is the microbial germ, bacteria, whatever that is? Um, and then what kind of strain is it? So there's a lot of determining factors. And then how wet is it? Right. So we got an evap coil, right? That we're removing humidity, so it gets wet. And the inside of the coil's wet, runs down, goes into the pan, goes out our condensate line, gets pumped out of the system, hopefully. Uh, but pressure difference in an opening. So we're talking fluid dynamics here and pressure dynamics. So we have a negative pressure, right? As it goes in, right? And a positive pressure on the outside. There's our pressure difference. With the air movement, also, we've got the moisture migrating to the outside of those fins. So now, if there's microbial there, they are migrating with the moisture in the air to the outside of the coil. So then there would be the distance. Most residential applications say, 10 inches to 15 inches distance would be a good
From the
application
coil?
from the surface being treated. And right now we're talking about the coil. So if you have
Okay.
an evap coil, and then across the evap coil, you got that metal plate that holds the thing together.
Yeah.
So many times I see a UV light right above that. And I'm like, that's awesome. You have the cleanest plate of metal in that whole system. No air is flowing across it. And it's like, it's not doing anything. So properly installed. So to properly treat an evap coil, could you stick one in? Well, possibly. SEER 2, those coils are getting bigger. So if you want, I call this a triple safe UV sanitation. One in the middle, one on each of the outside would get you pretty good. But really, really, if you base it on the science, you'd need two in the middle and then four on the outside. So that's 6 UV lamps on a SEER 2 evap coil to properly treat it. Are we going to do that? Probably not. And then each lamp is
Probably
one
not.
inch, right? One is a 1 inch cylinder. So if you put 6 of those in, well, guess what? That adds static resistance because you're trying to blow air across 6 inches of UV lamps. So I like UV technology, gotta be installed properly. Here's what I say: any device that puts an additive into the air as part of their technology is a no-go for me. We're trying to remove stuff from the
Yeah.
air, not put stuff into the air. So whether it is bipolar ionization, needlepoint ionization, it's called many different things, or photocatalytic oxidation, you know, PCO. Those are a
Ozone.
no-go for me. Some omit ozone, some don't. But the byproducts are often worse than the things we're trying to treat. First of all, 99% of our industry installs these devices and don't even know if there's any pollutants in the air. They don't even know what we're trying to accomplish. People ask me, John, what are you trying to accomplish? What are the pollutants you're going after? Well, I don't know. Well, then how do you know that this technology is going to do anything? And so, I don't know if you want me to go any deeper than that.
I mean, I think that covers it. You talked about the main particulates that you don't want to see being generated by the UV lights and some things that they need to look for. So, and placement, frankly. So, I've just seen, it seems like they're always sold as a it's like a bonus. Hey, you're getting a new furnace, you're getting a new air conditioner. Hey, for another $500 or $1,000, we can throw this Ream Halo or whatever the brand is on here, and you'll have even better air quality without considering duct leakage or sealing the ductwork or filtration. Like they're kind of missing some of these other things that should happen first, and they're
Or
getting sold
byproducts.
a yeah, and they're getting sold a product as a solution when they're ignoring the source of where their issues are coming from, right? So I think that's really important for homeowners to understand before they agree to pay for an air purification device. Is like, hey, let's take care of the source of the problems first, and let's not just stick a band-aid on this, bleeding artery, basically.
Right, and that's
So
why I developed my 6 key foundational. Let's do that first, and then we can talk about sundries, accessories, other things. But I'm telling, if you get those 6 things under control, you're well on your way to creating a clean, healthy environment.
yeah. So I'm just thinking, if a homeowner had, say, $500 or $1,000 to put towards meaningfully improving the indoor air quality in their home this summer, where do they spend that money first? And I know it's
Testing.
not a lot.
Testing. Let's identify if there is a
Okay.
problem, and if there is a problem, and they're symptomatic. Here's what I'm experiencing. Okay, well, we don't know what's causing that, right? You're being triggered. So let's spend $500. Let's run some preliminary tests. Let's get some useful data that we can make our next step decision on. And I
So this
think
would be one of the air things or the Aeronaut or whatever your Haven IQ, something like
well,
that.
if they're going to spend $500 with me, then I can bring, and most contractors can. I've been
Yeah.
using Air Advice for a long time. They just added formaldehyde to their device. That's good, solid data. And if I can go in there and run that, and people always say, "Oh, John, 30 minutes isn't enough." Yeah, you're right, but it's data.
Right.
So in
It's a
30
snapshot.
minutes, if I see something that tells me, well, maybe I better pay a little more attention to A, B, and C with more extensive. But the cool
Yeah.
thing about running a 30-minute snapshot, I can run a 30-minute in the living room, I can run a 30-minute in the primary bedroom or maybe the 2 kids' bedrooms, and now in 2 hours, I've got 4 snapshots of 4 different areas to really base my next steps. So it's
So
good
the
side.
yeah. And the Air Advice product, that's more of a professional grade thing. I think it costs a couple $1,000. So maybe
It is.
if somebody's calling an HVAC contractor, that could be something they ask, "Hey, do you have one of these devices that measures indoor air quality, measures and stuff like that?"
Yeah, but you pose the question, if a homeowner had $500 to spend, well, that would be a good start. Somebody with a device like Air Advice or handhelds that can really get you some solid data. Now, can they go buy an Air Things or something? Well, absolutely, they can. I don't know if it's going to be as accurate as the data that we can design, but if they're going to spend $500, I'd rather they spend it with me.
Well, to that point, I mean, if you're really wanting to tackle a home performance, a home insulation, a humidity problem, an air quality problem at home, you really want to identify the correct contractor to bring in and ask these kind of questions like what type of test do you do, what type of test, what do you identify with the air quality test? Can you do a blower door test? Do you test for duct leakage? Do you do thermal imaging? Are you going to do HVAC performance testing? And for, $500, you can get some stuff done, but it may cost you more to get a comprehensive analysis done of your house. But then you have a blueprint and a roadmap of what to do without guessing going forward. And that's really important because I can't tell you how many times I've gotten called into a situation where I'm the fourth, fifth, or sixth person contractor that they've called to try to solve the problem. And they've already spent five, 10, $20,000 trying to fix the problem, guessing at what it is, and it didn't fix the problem. So if you start off with a good analysis and a good diagnosis and you have a plan going forward, you're going to save a bunch of time, you're going to save a bunch of money and a bunch of headache going forward. So that's really a great tip on what to do first when you're trying to tackle these problems.
Yeah, and let me touch on something. 'Cause you mentioned a blower door, and it's becoming more and more commonplace for HVAC guys to have one and understand how to deploy it or not.
Yeah.
Hey, back to the $500, and I can go ahead and run some tests. Do I need to deploy a blower door? Maybe not. I've got my anemometer, right? I can do a worst case in any case depressurization using the fans that are available to me in the house, and I can do a little bit of pressure mapping. That and a smoke pencil, I don't even need to deploy a blower door. Now, will I need it later? Possibly, especially if I'm going to redesign a system or want to really target put some numbers to things. But just baselining a house with your anemometer, turning
Pressure
on
gauge.
the kitchen, the bathroom exhaust, the washer machine, any other things that may be in the home, and just doing some simple pressures with reference to outside, the attic, the crawl space, the an attached garage, only with available fans. And the cool thing about this is a live measurement based on what the house will give you. This is not a blower door at CFM 50, which quite possibly can be an unrealistic number because it's used for a specific reason. And
Yeah.
I've used blower doors in all kinds of different ways other than energy and getting an infiltration number. So it's a great diagnostic tool, but an anemometer, DG 700, DG 1000, DG 8, the one from Rector's
Solo.
yeah, the
Retrotech.
Solon? Yeah, those are all great. Do you need to deploy a blower? No, you really don't. You can get some good data relatively fast while you're running your air monitoring and really have a good understanding of what's going on in the house and what is the house doing,
Yeah.
not what is a blower door doing. Does that make sense?
Yeah, that's I interviewed Steve Rogers from the Energy Conservatory a month ago, and he said the exact same thing. He's like, if you're getting into home performance or an HVAC contractor and you want to learn more about how the houses operate, you need to have at minimum a DG8 or another kind of pressure gauge. A simple pressure
Yes.
gauge can tell you a lot about what's going on in houses. You didn't mention it, but I know you know this, room to room pressure differences when the heating cooling system is on versus off. If you've got a really hot room in the summertime or a really cold room, it doesn't matter really what season it is, but if you close the door to that bedroom with a pressure hose that's going under there connected to your gauge and the heating cooling system is on, you can tell if there's too much air going into that room or too much air coming out of that room simply if the number is positive or negative. And so it can really start giving you clues as to what's happening in the house and causing those problems.
Yes, I've always called it pressure mapping because when I go in, I pressure map a house. I think they call it zonal now. But
Yeah.
we've always called it pressure mapping. We moisture map a house and we chase the humidity. Um, what's interesting too, we always talk about stack effect and what that is.
Yeah.
I look hard at stratification, and that tells me how well my heating or air conditioning is performing by looking at stratification. versus stacking. I think it's all stacking to a point, but I think stratification is more of a mechanical effect, and being able to see where my temperature discrepancies are, especially in a two-story house where you've got that large discrepancy from the
Yeah.
first floor to the second. But that's all done with simple tools, and running the AC, running fan only, closing and opening doors, different things. um, to your point,
Yeah.
absolutely, which gets us into, I've been taking that little dive into that neutral pressure plane, and Steve Rogers does an amazing job explaining that. But man, that can tell us a lot. And just briefly, in order for air to move, a pressure difference and an opening. So if we look at a house and our neutral pressure plane is about center of the home, so if we're at neutral in the center of that home, that means there's no pressure difference.
And
As
you're
that
talking vertically center of the house. So
vertically,
if it's a
yes,
two-story house, in the middle, in between those 2 floors is the neutral pressure planes, what you're saying.
yes, and so there should be no infiltration there. Now, could there be windows? Oh, yeah, in a two-story and a three-story house, gets a little more difficult, but so the neutral means 0 pressure difference, so that means no air is moving. No, as we introduce exhaust fans and duct leakage, depending on where the system's located, crawl space, basement, or in an attic, well, that
Garage.
duct leakage and exhaust fans will now move that pressure plane. So if the center is 0, and we introduced the HVAC, and it's in a basement, and now we've got duct leakage, and now that neutral pressure plane drops. That means that our biggest pressure difference is going to be at the top. So by virtue of looking at where that lands, hey, I'm going to get my biggest bang for the dollar if my neutral pressure plane is always dropping to the lower one third of the house. So that means we've got very little pressure difference, so very little infiltration. Most of my infiltration is going to be happening at the ceiling, whether it's a single story or two-story. Now, when we go to do our air loss reduction, and let's say we're trying to be very aggressive at 20 or 30%, that's where we would go. Now, how do we manipulate that? So we can manipulate the neutral pressure plane. We can do wonderful things without actually even having to do air sealing. And we do that by introducing supply only ventilation. A lot of the industry's hung up on a balanced ventilation. Oh, we're going to take X amount of air out. We're going to bring X amount of air in. We're going to condition it, clean it up. And that's going to be our ventilation strategy, right?
Yeah.
As balance.
ERV, HRV is a balance system.
Yeah, or a dehumidifying ventilator. If we do supply only and we take into consideration during operation of our HVAC, supply only ventilation would force our neutral pressure plane to go one direction or other. We can control it. And so if we can, by way of supply only ventilation, force our neutral pressure plane one direction or the other, well, now we can really pay attention to where we need to focus our air sealing, and it's just amazing. So that's just
Yeah.
real quick.
I'd say
I need
you're
to
also
spend
gonna
some time
be
with Steve.
Yeah, and so, like, again, going back to how we opened this conversation about climate zone specific, you gotta be careful with an air supply only ventilation strategy in a humid climate because, again, if it's not going through a dehumidifier, it's going to bring in a bunch of humid air from the outside that's going to add more moisture to the house. So that's you gotta be careful with situations like that, and then, you know,
100%.
the ability to add, you know, an air cycler or a supply only ventilation to change the neutral pressure plane, it's also going to be more effective the tighter the house is, right? So, like, if you have a really leaky house, it's going to be virtually impossible for you to move that neutral pressure plane with 100 CFM of air coming in or whatever you've got designed. It's going to have to be a whole lot of air to make that thing move. So, focusing on, you know, the obvious air leaks that you can see either by there's light. I can see through the outside and there's spider webs and the gaps and stuff that go through the ceiling. If you could take care of that stuff first, that'd be the first thing, and then start measuring some of the simple pressure diagnostics. It's really going to help you understand what's happening with the house.
Yes, which brings me back to the why never changes, just the how. So the
Yeah.
dehumidifying ventilator is Yeah, that's the way to go. And so, one more caveat when we're talking about ventilation, and this is something that, so I designed the DF16. I've also designed an apparatus that will complement any ventilation strategy. And it would be running through a HEPA filter, 15 pounds of carbon, have an onboard reverse incline digital fan to make up for the resistance through 15 pounds of carbon, right? Pellets and a HEPA filter. So, for instance, if my dehumidifying ventilator coming in only has a MERV 8 filter, or a MERV 13. They don't fit very well. We have the opportunity of bringing in PM 2.5 and TVOCs and ground level ozone. We have the opportunity of doing that along with humidity, right? Depending on what apparatus you use. So if we're going to
Mm,
bring that air in, we're going to wring it out through a dehumidifying ventilator, but we want to clean it up running it through a HEPA filter, 15 pounds of carbon, get rid of all my TVOCs, any kind of pollutants from outside, including ground level ozone, and then deliver it to the air. If we need 200 CFM from our ventilator, it goes through that much uh, filtration. My fan will give back the 200 CFM to make sure our cycle's running right, and then deliver it to the house. I
yeah,
submitted it. We did a market analysis. We did material procurement, and we've ran it up the flagpole, and I've hit a block wall. Rector Seal is a big company. Their portfolio catalog is unbelievable, and they just bought Aspen Coils that makes air handler, so they're getting into that now.
okay,
And so it's a little harder to get things through. So Greg and I are going to try another push. I've got guys asking me for this. I've designed my own in dry climates that do this. And so that's my next kind of pet project I'm trying to push through.
yeah. So as we're kind of getting towards the end here, I'd have a couple other questions. So, we're in the humid season. We're talking about a lot of the byproducts of hot, humid houses. One of them being musty smells, funky, moldy, mildewy smells. So, like, walk me through like what's happening in a house when you have a funky smell like that, step by step. Where could that smell be coming from? And I know this is going to be different for every house, but like, what's your process of trying to diagnose where these moldy, damp smells come from in houses and how to get rid of them?
Woo! That's a
I
big
know it's a
one, Eric.
lot.
And smells, I've been doing this a long time. And when I have clients that come at me with smells, those are the hardest.
Yeah,
Every once in a while you get lucky. And it's like, well, hey, this was low hanging fruit. I found it. But a lot of
yeah,
times it's not. So in order to get that musty smell, a lot of time it's going to be building materials that have gotten damp. And so when we look at moisture intrusion, we've got let's say damp, and then we've got moist, and then we've got saturated.
okay,
Right? So dampness can come, easily. When I was in the hotel room and the PTAC wasn't doing its thing, everything felt damp. So
yeah,
it really wasn't wet, right? And so when things are moist, now we're moving along a little bit, and the moisture content is higher,
yeah,
and
yeah,
then they're saturating. I mean, it's dripping. So moisture on certain materials and fabrics and different things will create a musty smell. When you have mildew in your shower, that will create a musty smell because as those cells are multiplying and dividing, they're letting go of enzymes that can create an odor. We have dirty sock syndrome on evap coils all the time, and that's from those cells dividing and multiplying and releasing an enzyme that creates a smell. And so those are tough. So one we need to remove the source, and that would be the moisture, and then we need to dry out the material. Now that brings into question, what is the material? Is it an old rug? Is it a carpet? Is it drapery?
drywall,
Drywall?
wood,
It could be a multitude of anything. And
yeah,
so do you get to a point where if hey, you know what? I smell it. You got a rug, you're in a shower, it never gets dry. You come out, you drip on it, it will never get dry because we don't have any way to dry it. So maybe we get rid of the rug.
yeah.
How do you tell people, hey, you need to pull up the carpet in the basement because that's your source,
Yeah.
and you've got a basement. That's hey, you need to get rid of the carpet, bring it up, take care of any kind of moisture intrusion, put down a vinyl floor. That's a more friendly surface to deal with this stuff. So that's a hard sell. Hey, guess what? We got to take the bottom 4 feet of your drywall out of this whole house. Uh oh. Maybe you need a second opinion.
Yeah. I think the way that I would break this down for somebody is like, let's see what the relative humidity is inside your house first. And if it's higher in certain floors or in certain rooms of your house, that may indicate that there's a leak, an intrusion somewhere in that room, or a lot of air getting in that room from outside and bringing in more moisture. So you could do that first, and then you could use an infrared camera if you have access to one. Even the cheap ones that come on, smartphones. I recommend the Top Dons a lot. They're pretty inexpensive. If something's actively wet, it'll show on an infrared camera as a darker surface temperature, and then you could verify that by using a moisture meter, whether it's a pin moisture meter or a surface one. Place it over top of the spot that you see with the camera, and verify that it's wet. And then from there, you start drilling down. Like, all right, well, if I'm smelling something musty, it's got to be something where either there's a source of moisture potentially, so where plumbing is, or maybe where there's exposed ground underneath the house. If you have a cellar or crawl space, that's usually a really good place to start. Bathrooms that aren't ventilated properly, things like that. So all these things are what I would look at first if you have some kind of a smell problem in the house.
Yeah, 100%, and that's the direction I usually go. You definitely need a moisture meter. An IR camera is fantastic. You got to create a delta T in order to get some good readings. I found plenty of leaks or evidence of leakage using my IR camera. And then to your point, we start to moisture map. We start plotting our relative humidity, and then, hey, is that musty smell actually coming from inside the house, or is it outside coming in because we've got a pressure imbalance and infiltration? That very well could be. And then that brings up a whole, and each thing that we look at takes us in a different direction. And you take it as far as you can until you've eliminated all possible options on is this the source? And it can smells are tough, man. They're some of the toughest things that I've had to deal with.
I know, and especially because some people are way more sensitive to smells than other people, and so sometimes I'll go into a house, and normally I've got a pretty good sense of smell, but I'll just be sometimes I don't know what you're talking about, like, I don't smell it, and then other times I'm like, "Oh, yeah, absolutely," and I know where that's coming from because it's a common thing, like a dry sewer trap in the downstairs bathroom or something.
Yeah. I had a customer call me in for smells, and the first thing she does, she goes over to the wall and she puts her nose against it. She takes a big whiff and she's like, "John, it smells like onion and socks." It's like, how she knows that smell, I don't know. I would go over and I would humor her and I'd take a big old sniff of that wall. It's like, "Ma'am, I am sorry. I go places people shouldn't go, and I'm always subjected to things. Maybe my nose isn't the best, but I don't smell it." Onions
Yeah.
and socks is a pretty distinctive smell.
Sometimes I think it might be brain damage that they have, and they're not aware of it, and it's
Well,
giving them smells that they
that's
shouldn't
a
have, and I'm just
conversation for
like,
another
"Whew."
day, Eric. That's a
Yeah,
whole
I
conversation.
I am not that yeah, I cannot help you with that part of this problem, so
Yeah.
all right, last question, John. What's the one thing you would have every homeowner watching this do this week, if they've got any of these problems that we've talked about, the one thing they should do before they even talk about calling a contractor?
This may sound silly, but some basic house cleaning. If they've got a smell coming from somewhere, and I'm not questioning anybody's hygiene or their practices or behavior, I'm not, hey, do me a favor. Let's mop, let's vacuum, let's dust, let's do a topical cleaning, and then tell me how long or if all those smells come back. And that's just a simple thing that a homeowner can do. Can we break out and air things or whatever? And it's not going to identify a smell unless it's, you know, something pretty
Toxic
crazy.
or something?
Yeah, I would say that. It's like, oh, hey, you know what? My air conditioner isn't working. Do me a favor, go look at your panel, make sure your breaker didn't trip. So that's like low hanging something simple. Hey, just do a
Yeah.
topical cleaning and tell me it's gonna be fresh. How long does that take? Does the smell come back? Does it come back stronger, weaker? Does it come back at all? That's just kind of something simple. And it sounds silly, but that could go a long way. And I'm not suggesting in any way, shape, or form that you clean something with bleach and it's gonna make the mold go away. And that's not what I'm saying. But
Yeah.
if it's some basic just stuff, maybe that'll do it. That makes sense?
Yeah. And absolutely. And while you're at it cleaning your house, go and change your air filter because when's the last time that you changed the air filter? It might have been a year ago. And that thing looks like a quilt today. And
Right.
so you're
And then
smelling all the crap that's on that filter.
we added humidity to it. So it's different.
Yeah. Maybe it's you have a humidifier and on the system and the pad hasn't been replaced in 3 years and it's all nasty too.
Yeah.
The ductwork would be another one that I would look at. Open up the supply vents if you got them on your floor and see how many toys and kids' food and Cheerios and stuff are down in those ducts and vacuum it out. So, like, do some
Yeah.
basic stuff.
Everything's
Absolutely.
fine till the dog comes into the room. Bingo.
And then he lays down on top of the return vent and all of his hair and everything else goes into the
Oh
ductwork.
boy, yeah, I've seen, and that seems to be a favorite place for any kind of long hair dog to go lay by the return because that cools them down, and then you pull stuff out of the evap and you can knit a sweater.
Yeah, I had a lab that passed away a couple months ago, but after he was outside, he would come and put his head on top of the supply and just sit there and just get all the cold air coming up in his face. It was hilarious.
Yeah.
Well, John, this has been a great conversation as always. I always look forward to talking with you. You're going to be speaking at the NCI Summit, and that is September 1st through the 3rd, I believe, in Tennessee.
In Pigeon
So,
Forge at, Dollywood, it's actually the hotel, like, adjacent to that.
yeah,
Wonderful place. If you haven't been in that area, maybe come up a little early, stay a little, go to Gatlinburg, Pigeon Forge, the Smoky Mountains. Wonderful
yeah,
little, getaway, but yes, I will be speaking. I'm excited. This is gonna be something a little different for me. Normally, I'm doing a technical talk and talking building science and HVAC and indoor air quality. This one's gonna be a little different, and they've given me a little freedom, and I want to help contractors, get started, or no matter where their journey is in high performance HVAC and high performance indoor air quality, building science, just high performance altogether. And it's going to be, a lot of my personal experiences and my journey, and I'm excited. And David Richardson's been and Dominic very generous to allow me to do this, and I'm excited. Something different for me.
yeah. I'm definitely looking forward to it. I'll be there for sure. And if anybody else is interested in going to the summit, just Google NCI National Comfort Institute, NCI Summit, and you can get the registration page there and get signed up. But I'll look forward to seeing you here in about, I guess it's about 2 months from now.
Yeah, we'll have to get ice cream.
Get some ice cream or something. All right, John, I appreciate your time, man.
Yes.